All right. So this is the PowerPoint, section 1.6, solving linear equalities. And if I stop my slideshow from the current. All right. Kind of important. Click on each one of these. I'm not going to do it within this video, but I'd ask you to click on each one of these videos, important videos from Khan Academy on inequality. So please watch these three. I'm not going to show them out of this PowerPoint. Inequality is a sentence with a less than, all right, a greater than symbol, less than or equal to, or greater than or equal to. All right, these two are called strict inequalities, less than and greater than, strict. This is less than, or it could be equal to, greater than, or equal to. An example, 3x minus 5 is less than 6 minus 2x. To solve an inequality is to find all the values that make the inequality true. Each of these numbers is called a solution. And the set of all the solutions is what's known as a solution set. All right, inequalities that have the same solution set are called equivalent inequalities. For any real numbers, basic algebra, for any real numbers A, B, and C, if A is less than B, if I add the same value to both sides, C, A plus C would be less than B plus C. Likewise, multiplication property, if A is smaller than B and I multiply both sides by C, C is a greater than zero, a positive value. The product of A times C will be less than the product of B times C. However, when you multiply or divide both sides of an inequality by a negative value, C is less than zero, it's negative, you have to flip the inequality. When both sides of an inequality are multiplied or divided by a negative number, we must reverse the inequality sign. So this is the case where this went from less than to greater than because C was a negative value less than zero. This is kind of a proof. We've heard this about flipping the inequality when you multiply and divide by a negative value. This video is a proof of that very statement. So if you're interested, check that video out. Solve each of the following, then graph the solution set. Letter A. All right, so we just rewrite it. 3x minus 5 less than 6 minus 2x. And what we've done here is to add 2x to both sides. So I brought the minus 2x onto the other side as a positive. 3x plus 2x is 5x. And then I brought the negative 5 onto the other side. So, swapping sides, even though this is an inequality, this minus 5 becomes a positive when I bring it onto the other side. All right, 5x is less than 11, dividing both sides by 5, x is less than, it's a strict inequality, x is less than 11 fifths. All right, so I can write a couple of ways. In set notation, instead of all x values, such that x is less than 11 fifths, or I could write it in what's called interval notation, all right, from negative infinity all the way to 11 fifths. Notice parenthesis, a strict inequality, all right, parenthesis. This is not strict, it's greater than or equal, so we're not going to have parentheses. We have brackets. First of all right, he finishes this off by graphing this. All right, there's your 11 fifths, which is 2 and a fifth. Everything that's less than that, but it's a strict inequality, so it's a parenthesis. It's not less than or equal to, simply less than. Letter B, rewriting it. Here what we did is brought the 10x over to the other side as a negative 7 combined with a negative 10 is a negative 17. Now I'm going to take the 13, bring it on the other side as a negative 4 combined with that negative 13 that I brought onto the other side, negative 4 and a negative 13, negative 17. Now notice I'm about to divide through by a negative. I have to be aware that this inequality is going to reverse itself. All right, dividing both sides by a negative 17 would cancel out here. Negative 17 divided by negative 17 is 1. But notice, because I had to divide by a negative, the direction of the inequality reversed itself. All right, x is less than or equal to 1. There it is in set notation. Here it is in interval notation, going all the way to negative infinity. Notice, negative and positive infinity are always denoted with a parenthesis. But it's greater than or equal to, so it's a bracket as opposed to a parenthesis. All right, no, these were parentheses because just less than, strict inequality, less than or equal to it's a bracket. And then he graphs it with a bracket, all the values that are less than or equal to 1 all the way out here. It's a negative infinity. That's how you see it in interval notation. All right, when two inequalities are joined by the word and or the word or, you've got what's called a compound inequality. All right, it's the conjunction. The word and is considered to be a conjunction. All right, here's a sentence here: minus 3 is less than 2x plus 5, and 2x plus 5 is less than 7. Or we could write it as a disjunction using the word or. 2x minus 5 is less than or equal to minus 7, or 2x minus 5 is greater than 1. We're going to see in most cases, and when you graph it, the graphs converge on one another. In an or situation, I think of oars of a boat that are going in opposite directions. But that's not always true, because if you happen, in solving the inequality, if you happen to divide by a negative, all bets are off, because the direction of inequality would reverse itself. So we'll see how that works out here. All right, solve. These are the easiest to solve, the and problems. All right. Minus 3 is less than 2x plus 5, and 2x plus 5 is less than or equal to 7. All right, so he writes it. What he does here, he's trying to get x by itself. So he starts out by subtracting 5 here, subtracting 5 there, and subtracting 5 there. Minus 3 minus 5 is minus 8, plus 5 minus 5 cancels out. 7 subtract 5 is 2. And now he's going to divide everything through by 2. Minus 8 divided by 2. Why is he dividing by 2? Because he wants to negate this 2 times. So minus 8 divided by 2 is minus 4. 2x divided by 2, the 2's would cancel out. 2 divided by itself is 1. Now notice what's happening here. All right, this is in set notation. Now in interval notation, because of the greater than or equal to, we've got a bracket. All right, on the other side, the left side is a strict inequality. That's a parenthesis. And in graphing, you see that denoted, right? X is between negative 4 and 1, but negative 4 is not included because it's a strict inequality. It's a parenthesis, but notice X could be less than or equal to 1. That's why I've got a bracket there. All right, solve the or problem. We just do it individually. All right, solving the left side here, we're adding 5 to both sides. Minus 7 plus 5 would be a minus 2, dividing both sides by 2 in a moment. And here I added 5 to both sides. Dividing through by 2, x is less than or equal to negative 1, or dividing both sides of the second part of the inequality by 2, x is greater than 3. All right, 2 divided by 2 cancel out. 6 divided by 3 is 2. So there it is. This is repeated in what's called set notation, a set of all x values such that, and then you've got some interval notation. You've got this part union with these values, or it could be these values. Either one of these would satisfy. All right. So how do you denote that? You take these set of values and you union them with the other set of values, and that's what it looks like. All right. Less than or equal to negative 1, a bracket because of the or equal to part going to the left. X is greater than 3, strict inequality. It's a parenthesis and going all the way out to infinity. So here it is, set notation, interval notation, and then the inequality, compound inequality graphed. A practical problem here. For her interior decorating job, Natalie can be paid in one of two ways. Plan A, she gets $250 plus $10 an hour, or she could get just Plan B gives her $20 an hour. Suppose that a job takes N hours. For what values of N is Plan B better than Plan A? Well, for a 20-hour job, N is 20. So in Plan A, she's getting $250 up front plus $10 for every hour she works. She works 20 hours. So 10 times 20 would be 200. 200 plus 250, she's getting paid $450. Plan B, she flat out gets $20 an hour. So working 20 hours, she only gets $400. So here's a case for 20 hours. Plan A is better. Now for 30 hours, Plan A would give her $250 plus $10 an hour times 30 hours. That'd be $300 plus $250, $550. Plan B at 30 hours at $20 an hour gives her $600. Now notice at 30 hours, Plan B is a better deal for her. So we translate this to an inequality. When is plan B going to be greater than or equal to plan A? All right, here's plan B, $20 times number of hours. Plan A is $250 plus $10 times how many hours. So solving the inequality here, I'm going to subtract 10n on both sides, divide through by 10. Whenever she works 25 or more hours, plan B is going to be a better plan for her. At 25 hours, plan A would give her 500, plan B it would also give her. We have seen that plan B pays more for 30 hours. Since 30 is bigger than 25, this provides a partial check. But we still kind of summarize it and say, hey, whenever she works 25 or more hours, exactly 25, A and Plan B pay the same thing. But anything over 25 hours, Plan B is a better deal for Natalia. I'm not even sure I'm pronouncing that right. Natalie, I guess. All right. And that's nothing that you have to concern yourself about. That is nothing that you have to concern yourself